Hello friends, in this video I will discuss the whole process of bending of two-ply sheet in Abaqus software. Now I am choosing with standard oblique explicit model. First of all, I will set work directory. Now I will go to parts and I am using double click on the parts. First of all, I will make blank of two-ply sheet, 2D deformable shell. Continue. I am choosing here line and I am making the blank of two-ply sheet. Now I will give dimension to this blank 75, again 75 and again 75 like this. The total length of the blank is 150 mm and the overall thickness of the blank is 2 mm. 0.6 mm is used for SS and 1.4 mm for aluminum. 0.6 and opposite side also I am taking 0.6. Here I am taking 1.4 mm thickness of aluminum. Now I am clicking on mouse and now I am right clicking on the mouse and choosing cancel procedure. Done. Tools. I am choosing here partition, face, use shortest path between 2 points. Click here and I am clicking also here, create partition and after that done. Now I am using double click on parts and I am making die 2D analytical result wire continue. I am choosing here point minus 75 0 minus 45 0 75 comma 0 45 comma 0 and 0 comma minus 45. Out of it view. Now I am making die like this. I am taking radius 15 mm, save and select this. Now I want to offset 2 mm, click this, click this and done, and 2 mm offset. Okay. Extend this line. Extend this line also. Now I am using trim command like this, like this, like this, like this, and like this. Now the radius for the die is 17 mm. I am giving here 5 mm radius, and here also. Now I am using double click on mouse. Sorry, I am using right click on the mouse and choosing cancel procedure. Done. Now I am taking reference point to this point. After clicking, or you can say after taking this point as a reference point, I am going into die and choosing engineering features and finally inertias. And I have used double click on the inertias. Now continue and click select point to assign point mass oblique inertia, and I am clicking on reference point and then done. Here I am taking 10. Now I am using double click on parts and I will make punch. 2D electrical rigid wire continue. Point minus 45 plus 45 minus 45 plus 45 0, 0. Now I am making punch for bending purpose. I am giving radius 15 mm to the punch. Now I am using right click on the mouse and choosing cancel procedure and then done. I am taking reference point on the punch like this. Punch, engineering features, inertias, continue, select reference point and done. And I am taking 10. Okay. Now I am going to materials section and using double click on the materials, and here I am writing SS general. I am picking density is 7.8 E minus 0.06. Now I am going to mechanical and picking elasticity, and I am clicking on elastic Young modulus, that is 200 gigapascal. And I am taking cohesion ratio 2.9. Now I am clicking on plasticity, and after that plastic. Here I had to paste yield stress and plastic strain. Now I am going again to materials, and I am using double click on materials. Here I am giving name aluminum, and I am picking journal and then density 2.71 E minus 0.06. Then mechanical elasticity, elastic Young modulus 70 gigapascal, cohesion ratio 0.33. Now I have to put here yield stress and plastic strain. Now section manager, create section 1. I am taking section 1 as a stainless steel. Create section 2. I am taking aluminum as section 2. Now section assignment manager. Here I am selecting blank. Section assignment manager, create. Select the region to be assigned a section. I am taking upper portion of the blank. Click and done. Here I am taking SS as a upper part of the blank. Bottom part, for bottom part I am taking section 2, that is aluminum. Now done. I am going to mesh section, and I will choose seed edges. Now I am selecting this, taking shift button and again selecting the opposite dimension, then done. By number I am giving 4 number of elements. Now I am selecting this, saved, and I am also selecting this opposite side, this opposite side, then done. And I am taking 8 number of elements. I am selecting here and also selecting here, then done. Here I am taking 75 elements. For this I am taking 150 elements. For rest part I am taking 75 elements. Then done. Now I am going to mesh part and clicking on yes. Here you can see finite elements of the blank. Now I am going to mesh, selecting element type and selecting this blank, whole blank, then done. And here I am taking plane strain, then done. Now I am going for assembly purpose and I am choosing this create instance. Here I am selecting blank die and punch and then OK. Here I am choosing this translate instance and I am selecting blank, then done. I am choosing this point and selecting this point. OK. Now I am again selecting translate instance and selecting this punch, done. Selecting this point and also this point. OK. Now I am going to steps and double clicking on the steps. I am taking here initial and selecting here dynamic explicit. Continue. OK. I am going to interactions, double clicking on interactions. Here I am taking initials, surface to surface explicit, and select the first surface. Here I have to select master surface, and I am selecting the bottom line of the blank like this. Using shift done, like selecting this and done. Now I have to select die, then done. Here the interaction will be between bottom part of the blank and inner side of the die. So I have to select magenta. Now penalty contact method, I am choosing property, contact, mechanical, tangential behavior, frictionless, penalty. Here I am giving the value of friction is 0.1. Okay. Then okay. Again I am using double click on interactions. And I am taking here step 1, surface to surface explicit, then continue. And for master surface, I am selecting upper part, top part of the blank using shift button, then done. Now I am clicking on surface and selecting the punch, then done. The interaction will be outer part of the punch and top portion of the blank. So I am choosing yellow. Penalty contact method, property 2, interaction property 2, mechanical, tangential behavior, penalty, and I have to give the value of friction between punch and die, punch and blank, and the value of friction will be 0.15. Okay. Now I am going for amplitudes. Here I am putting 0, here also 0, and here I am putting 1, and also here 1. Now I am using double click on boundary conditions. I am taking here initial and symmetry, continue, then click on the reference point of the die, then done. Here I am choosing the encaster. Okay. Now I am again using double click on boundary conditions, and I am choosing displacement rotation, and here I am taking step 1, and I am selecting reference point of the punch. Here I am putting minus 39.15, amplitude 1. Okay. Now I am going to job. Here I will create job 1. Now I will using submit button. Here processing of bending of 2-ply sheet has been started, and after some time the bending of 2-ply sheet will be completed, and after that we will discuss the process of springback of 2-ply sheet in V bending by using Abaqus software. in the monitor section, you can observe the process of bending of two-ply sheet in V-die. The processing of bending will be completed when we will get 1 into the column of step time. Now we are observing the step time is 0.15. When it will be 1, the processing of bending of two-ply sheet will be completed. Now we wait for this. half bending process has been completed. Now another half has been started. Now 75% of bending has been completed, and we are going for another 25% bending. %90 of bending has been completed, and we are waiting for another 10% bending. The process of bending has been completed. Now we can see the bending by clicking the results section. This is final state and this is initial state. Final, initial. Here you can see the stress and the value of stress. You can read here. Now I am going to perform a spring back of 2-ply sheet. For this, I have copied this model. Now I am deleting die. Now punch. All 4 surfaces. Step 1. Interaction 1. I am deleting interaction properties 1 and 2. Now I am deleting amplitude 1. I am also deleting boundary condition 1. Now I am going to steps, and I am using 2 clicks on steps. I am taking here initial static journal, then continue on. Now I am going to boundary conditions. I am selecting step 1 and choosing velocity oblique angular velocity. Continue. I am selecting this bottom point, this bottom center point, then done. Here I am giving 0 values, then OK. Now I am going to predefine fades. By double clicking, I will get this. Now I am selecting here initial, and here initial state, then continue. Now I am selecting the whole blank, then done. And here I am writing job 1. Now I am going to job and create job 2 from model 1 copy. Then OK. Now I am using submit button. Now process is going on. After completing this process, we can see the springback in the 2-ply sheet. Here, by clicking results, we can observe the springback into this 2-ply sheet like this. This is springback. Okay. It is initial state and it is final state. The final state shows the springback in the 2-ply sheet. Okay. The process of bending, and after that, the process of springback has been completed. Thank you. To listen me carefully.